Hello, 8th grade science students. Mr. Briding here to go over acceleration calculations with you. This is going to mostly be on the computer that you're going to be answering these questions, and your teacher, either Mrs. Stocking, Mr. Ambruso, or myself, we're going to have a grid up for you to tell you whether you're getting these right or wrong. And the number that you get right or wrong is going to help determine how many stamps that you're able to get with this assignment. All right. Now, what I'm really going to want to go over with you guys is what do you need to know, and then also the quick lecture notes. All right. So hopefully this is a quick video. So we've got the success questions, which are going to be like, how do you calculate simple acceleration? And we've got the other one, which is how do you calculate more complex acceleration calculations. On the quiz, you'll for the most part only see this first one here, which is simple acceleration calculations. The more complex ones are for those of you that like to be challenged a little bit. All right. Let's go ahead. Here are the lecture notes for this. So we've got acceleration, and we want to talk about real quick, what is acceleration? And acceleration is essentially any change in velocity, which means it could be speeding up, it could be slowing down, or it could be a change in direction. So if you think of you're driving in your car, la-di-da-di-da, or at least maybe not you're driving, but you know, one of the people that love you and takes care of you and takes you all your different places, you know, they're driving along and you're just in the passenger seat, you know, how many accelerators are there in that vehicle? Well, one would be the actual accelerator, right? Two would be the brake. And three would be the steering wheel. Any one of those could either speed up the vehicle, could slow it down, or change the direction. So there is no such thing as the word deceleration, at least not in physics. There is just acceleration, and that is to indicate that there is any change in velocity. So even if something were going the same speed, if it's changing direction, that is still considered acceleration. It still takes a force to happen. All right, now, how do we actually calculate acceleration? Well, we need to know a few different things. And there's actually a couple different ways that we can calculate acceleration. The simple way, the way that you have to use on the quiz, or you have to know how to use this one on the quiz, and that is, acceleration is the change in velocity divided by how much time it takes for that change in velocity. All right? So the way that we can find change in velocity is just by taking the final velocity and subtracting the initial velocity. So let's say a car starts out at 0 meters per second and gets up to 50 meters per second. That change is, or the difference between those two is 50 meters per second, right? So 50 minus 0, 50. If it starts out at 10 and ends out at 50, then that change is only 40. Or if it starts out at 20 and ends out at 50, now we're looking at a change of only 30 meters per second. The next thing is we have to divide it by the amount of time it takes it for it to accelerate. So for example, let's say a car starts out at 0 meters per second and it gets up to 30 meters per second, and it takes 10 seconds to do that. Well, we have to think, well, how much did it change every single second? So it started out 0, ended out at 30, so the change was 30. It took 10 seconds to do that. So 30 divided by 10, and we get 3. So if you think about that, okay, well, it changed by 3 meters per second every single second, right? And so that gives us a really weird unit of measurement for acceleration. That gives us meters per second squared, okay? This is only a unit. It has nothing to do with the value of the acceleration. So it doesn't tell you what to do with those numbers at all. So please don't square an answer or anything like that. This is just saying, if I said 5 meters per second squared, I'm really saying it's accelerating, or the velocity is changing 5 meters per second every single second. So that's why there's that weird 2 there. That's why the second is squared. And it's a little bit confusing, but that's the reason why, because it's changing it's a rate of change and a rate of change. all right? Now, there's some more advanced ways that we can use acceleration. So we can actually use acceleration in time to find distance that something travels. This is often used when we're talking about a falling object. So if we want to know, like let's say we know rate of acceleration on Earth due to gravity is 10, and if we know how long it takes for something to fall, so if I were to drop a penny off the Empire State Building, let's say it takes 10 seconds to fall, I could actually calculate how tall the Empire State Building is based off of how long it took for that object to fall. Another thing we can do is acceleration could also be found if we know the distance that something's accelerating and the amount of time, okay? And that is assuming that the object started at a certain velocity of 0, all right? And then time can also be calculated, again, as long as we know the distance and we know the acceleration, we can assume that it started out at a velocity of 0. It's easy to find time. Now, whenever we do these, we have to follow our PEMDAS rules, right? Our order of operations. Please excuse my dear Aunt Sally or whatever you guys use nowadays. But first it's parentheses, exponents, multiplication and division, and then addition and subtraction. So in this case, you would take 1/2 of acceleration and then multiply that by the time squared, because the first thing you would want to do is you want to do time squared and then multiply that by acceleration and 1/2 and then a 1/2. All right. Now, you're going to be doing 35 problems for acceleration, and it's broken down here how to get each stamp. So for the first 10 problems, you get a stamp, and then you get to 20, you get another stamp, 30, you get another stamp, and then if you get to 35, you get all 4 stamps. All right. There may be a little bonus in for you if you're able to get all 35 questions absolutely correct, because some of them are pretty tough. They do get a little bit tougher towards the end. But I hope you guys have fun with these and enjoy. I will see you guys around.